Namaskar friends, welcome to session number 30 in our course on work system design, and I am a bit excited and happy today that today we are going to finish 50% of our discussion on this topic. So today is the last session for week 6, and from next week our discussion will be towards the next 50% of our course on work system design. What we have understood in the first 50% of the course, we have tried to understand the concept of productivity. We have tried to understand that we need to improve the productivity. What are the various reasons for low productivity? What are the causes of low productivity? How productivity can be increased or the productivity improvement techniques. So the first purpose is to find out that why we are studying this course. And we have established that a systematic work study or the design of the work system can definitely improve the productivity, efficiency and effectiveness of any organization, whether it is into manufacturing or it is into the banking or it is into the hotel or service industry, aviation industry. So these principles are relevant to each and every sector of business. Once we know that productivity can be improved, we have found out or we have discussed the techniques for improving the productivity. And in that, the first thing is the method study. At each and every place, I think I have taken this example 2-3 times, that this recording activity that we are doing is also a kind of work that is being performed. How it can be done in a better manner? Apart from the content that is being discussed, there are other aspects also, like the design of this studio, the lighting arrangement, the air conditioning environment, the acoustics of this room, the environment that the speaker is getting for recording the session, the type of equipment the person is or the speaker has been provided with for recording the session. So this is also a kind of work that is being done, and how it can be improved further, we can always look for the opportunities. So we have seen that work is being done in all spheres of our life, and we can always try to improve the way we are doing our work. Since I am a mechanical engineer, so most of our examples are related to mechanical engineering only. But we have seen other examples as well. As if you can refer to the last session, we have taken an example of a micro motion study where a person is going to a washroom and he is going to shave. So how the micro motions can be used to depict the various activities that the person do, or the various micro motions that the person perform while doing the shaving operation. So it is not that all examples are from mechanical engineering, but we have tried to understand the concepts of method study with the help of various examples. In method study, what we have covered? We have covered operation process chart, we have covered flow process chart, within flow process chart, types of flow process charts, we have covered two-handed process chart, we have covered multi-activity charts, we have covered flow diagrams, we have covered string diagrams, we have covered principles of motion economy. Then in the last session we have studied thermalics, we have tried to understand the basic concept of micro motion study. So all these techniques can be employed to improve the current way or method of doing the work. So we have a standard method of doing our work. For example, a lady at a house or in a countryside doesn't have a washing machine, so she is washing the clothes with her hands, manually washing the clothes. She may be doing it for years and years together, and as she has been taught by her mother or mother-in-law, she is performing her task. Or a potter is doing some work, he is using the potter wheel to make the pottery items. Some standard procedure or protocol the person is following in doing the task, and as he has been taught, he is doing the task in the similar manner. But as a work study analyst, if we analyze how the work is being done, and scientifically try to examine it by questioning technique, that why the work is being done in this manner only. Can there be a better method of doing this work? Can there be a better sequence of activities which can help to economize the effort of this lady and this potter who is doing this pottery, or who is trying to make the items out of clay? Certainly there are scopes for improvement. And today we are going to see the SIMO chart, which is another technique which will help us to examine the work at the micro motion level. So whatever we are studying, there are maybe inputs which can help us to improve the current method of doing the work. So after method study, we will focus our attention on the another important technique which can help us to improve the productivity of our organization, and that is work measurement or time study. So first we are trying to find out better method of doing the work. Then we will try to time this better method and find out the standard time for doing the work using the standard procedure which is being established out of method study. Now coming on to today's discussion, we have started our discussion from the broader or the bird's eye level. We have drawn an operation process chart of the various operations processes being done in the industry. From operation process chart, we have gone to the more detailed flow process chart, then to the further detailing when a person is using both his hands to perform the work, we have gone to two-handed process chart. Then we have seen a man-machine chart where a man is operating the different machines. Then we have jumped on to the string diagram which can help us to economize the movement of the worker and material in the shop floor or to redesign our layout. Then we have seen the principles of motion economy related to the use of human body, the design of the workplace, the design of tools and equipment, or the arrangement of workplace. Further, we boiled down our discussion to the micro motions of the human body. Then we have seen thermalics, and from thermalics now we are trying to relate these thermalics with time and try to find out that how the unnecessary body motions can be avoided. So we will try in today's session, we will try to understand the basic concept of SIMO chart, the definition of SIMO chart, how to construct a SIMO chart, and how it can be useful to us in economizing the efforts of our workers. So very quickly now, I think the discussion part has been quite longer today because I am feeling a bit happy reaching the 50% mark for our course. So I have just tried to revise what we have covered till now, because from next week our discussion will be towards the last 50%. So first 50% we have covered, last 50% is remaining. So coming on to the discussion, that is the SIMO chart. SIMO stands for simultaneous motion cycle chart. So as we know that we are currently discussing micro motion study, and it is used, as you remember, I think I will go to first that only, it is used for short cycle time activities only. I think it is not in this particular slide, but it will definitely come in today's discussion, that it is used for short interval or short cycle time activities. So SIMO chart stands for simultaneous motion cycle chart. So motions are micro motions and the cycles are short cycles, and then we try to identify the basic thermalics or the basic micro motions and try to plot them in the form of a chart. So simultaneously motion cycle. So cycle is basically related to the time domain and the motion is related to the micro motions. So basically we will try to see, or we will try to divide the work into the micro motions, and we will try to plot these micro motions in the sequential manner, and then in respect of the time taken for each micro motion in terms of wings. So it is one of the micro motion technique devised by Gilbreth. This name has come numerous times, considered to be one of the leaders in the field of, or the developers of the time and motion study techniques, and it presents what is SIMO chart. This is related to Gilbreth, one of the important figures in time and motion study. It presents graphically the separable steps of each pertinent limb of the operator under study. So, the operator is performing his task, there are separable micro motions which he is doing. So, we are trying to record those micro motions and plot them in the form of a SIMO chart, and these can be done for both the limbs. It can be left hand and right hand. If we are using our feet also, maybe we can try to see that which of the thermalics or which of the micro motions can be used for the other limbs as well. But normally we see when the work is being done by hand, we use the left hand and right hand motions or micro motions only. The SIMO chart is the micro motion form of the man type of flow process chart. So, usually we focus on the man in this case. A SIMO chart is a chart often based on film analysis. We have already seen that using thermalics or in micro motion study, how do we perform the study. So, first we have to film the whole operation or different cycles of the operation, different number of cycles for the operation. So, first is film, then analysis of the film, then finding out or identifying the basic micro motions and then plotting them. So, this is a standard sequence of doing the analysis in micro motion study. A SIMO chart is a chart often based on the film analysis. So, this is the foremost maybe input that goes into the construction of the SIMO chart. And film analysis, then it is used to record simultaneously on a common time scale the thermalics. So, common time scale, this time scale is in terms of winks, which we have already seen that what do we mean by this unit of time wink. One wink is equal to 1/2000 of a minute. So, the time is also there, the micro motion is there in the form of thermalics. So, these are the two inputs. So, we need to record the time and first we need to know that what are the various thermalics. So, once we have recorded the film, we can analyze the film in a very slow motion and try to identify that what are the basic motions being done by the worker. So, these basic motions can be transport, empty transport, loaded, search, select, find, use, there are position, preposition. So, we will see all these thermalics, the time is also noted and then we try to plot it in the form of a SIMO chart. But how we will get these thermalics or micro motion, these are taken from the film that we have already recorded. After the analysis of the film, we will break down the total work into the micro motions. In other words, it is a two-handed process chart in the terms of thermalics with a time scale. And if you remember, refer back to our discussion on two-handed process chart. In two-handed process chart, we have used the process chart symbols, but with a slightly modified definition in case of two-handed process chart, because the standard process chart symbols that we have used for constructing a operation process chart, they have a meaning for each and every symbol. The circle stands for operation, the square stands for inspection, the arrow sign stands for transportation, the inverted triangle stands for storage. So, we have different process chart symbol. D stands for delay. So, we have these process chart symbols and we use them for constructing operation process chart. But when we use the similar symbols for constructing a two-handed process chart, there is a little bit of maybe variation there, but those symbols are used for constructing a two-handed process chart with little variation. But here we are not going to use those symbols, we are going to use the symbols that we used for thermalics. And please refer back to the previous session that we had. I have tried to explain to the best of my capability each and every symbol that is used in thermalics, or that is a thermalic and that is used in the micro motion study. So, those symbols will be used in constructing the SIMO chart and not the operation chart symbols that we have used earlier or the symbols that we have used for constructing the two-handed process chart. So, in other words, our SIMO chart can be analogous to our two-handed process chart, but the symbols will be different. In other words, the two-handed process chart is drawn in terms of thermalics within the time scale. So, we will draw it in the similar manner only, but with different notations and different symbols. It will be drawn. The template may remain same as in case of two-handed process chart, but the symbols will be different. Uses of SIMO chart, I think this I have highlighted. SIMO chart is used for micro motion analysis. Micro motions are the various thermalics. For example, this I have already told, this word is going to come in today's session, short cycle repetitive jobs. So, usually micro motion study is conducted for short cycle repetitive jobs like inspection, packing, etc., and high order skilled job like component assembly. So, when we have taken this example numerous times, assembly of nut and bolt and a washer. So, such type of repetitive short cycle jobs are usually analyzed using the SIMO charts. A SIMO chart is used to show the relationship between the different limbs of a worker with records of duration of micro motion. So, duration is in terms of time, and the relationship between the different limbs of a worker. So, the different limbs are performing the various micro motions. So, basically a SIMO chart will show you the micro motions in terms of time, that what is the time taken for each micro motion. For example, at an instant it can be found what one hand is doing with respect to the another in terms of the thermalic. So, we will see with examples, maybe with sentences the things may not be that clear, but once you see a actual SIMO chart, you will see what left hand is doing, what right hand is doing, and what is the time scale in terms of winks. From the analysis shown above, motions of the two hands or the other body, I have already told mostly it is with hands only, but or the other body members involved in doing an operation, inefficient motion pattern can be identified. Very important, because we want to economize the effort of the worker. So, wherever inefficiencies are there in terms of body movement, that can be avoided, and any violation of the principle of motion economy can easily be noticed. So, we can see that where we are not following the standard protocols, the standard principles, and wherever we are digressing or we are moving away from the standard protocol, that can be easily identified with the help of a SIMO chart. The chart helps in improving the method of doing an operation so that the balanced two-hand action with coordinated foot and eye motions can be achieved, and ineffective motions can either be reduced or eliminated. So, these ineffective motions we want to reduce, we want to eliminate, and only focus on improving the current method of doing the job. So, our target using a SIMO chart is to identify the unnecessary micro motions that have creeped up because of habits or because of the way we have been taught the things or taught to do the things. Those things we need to identify, we need to plot, and then we need to eliminate, and then design a better method or better sequence or pattern of these micro motions, and then compare the two methods. If the new method is better in terms of time saving, in terms of effort saving, we have to install and maintain the new method of doing the work, and SIMO chart will help us in this regard. Now, the most important slide, our target is improving the present method, and SIMO chart will act as a technique for achieving that objective. Thermalics in the SIMO chart are critically examined to explore the possibilities of. Now, how we will find out the better method? In the previous slide we have seen that our target is to eliminate the unnecessary motion. So, how we can identify them? So, our target is removing or eliminating the unproductive thermalics. And what are these unproductive thermalics? Such as find, select, avoidable, delay. So, we have seen that there are effective thermalics, there are ineffective thermalics or unproductive thermalics. So, we can focus on the unproductive thermalics and try to eliminate them or reduce their frequency. Resequencing of the productive thermalics such as assemble and disassemble. So, we can try to locate, we can try to identify the thermalics or the micro motions which are not adding efficiency into our operation and try to eliminate them, and then we can try to resequence the thermalics in order to improve the overall operational efficiency. Now, steps for constructing the SIMO chart, let us quickly see these steps. A micro motion based film is recorded. So, first we need to have a film in which we need to focus on the micro motions. So, it is a film of a worker doing his task in a normal way, but we know that we have to focus on his or her micro motion. So, we must, when we are filming, we must keep in mind that our target is to analyze the micro motions of the worker. Therefore, in the beginning only we must be sure that the technique or the cameras or the instruments or the equipment that we are using to record the worker is later on going to help us analyze the things frame by frame, so that we are able to identify the various micro motions being done by the worker. So, we need to identify our equipment judiciously. So, micro motion based film is recorded as the worker performs the job, and a wink counter, that is a timing device, is placed in the field of the view. So, what are the two inputs for making a SIMO chart? These are the micro motions being done by the worker, and the second one is the time, and both we are trying to get a input. The micro motions we will get from the film, and the time we will get from the timing device. The film thus obtained after the whole cycle is viewed for the analysis. The work study engineer analyzes the film frame by frame, step by step, in a slow motion, concentrating first on the left hand and then on the right hand movement. So, he will try to analyze the micro motions of the left hand and the right hand, and then try to list them, maybe transport empty, grasp, transport loaded, release. Up to that level of micro motion he has to jot down, or he has to write down, or he has to list the various micro motions being done by the worker by analyzing the film which has been recorded of the worker performing the task. The data noted in the above step is recorded in the form of a thermalics chart, and the duration of the actual movement are also read from the wink counter, which is the timing device. A SIMO chart is prepared at this stage for further study and analysis. How a SIMO chart will look like, we will quickly have few examples towards the end of today's session. This SIMO chart of the existing method is subjected to a questioning procedure, very important, and we will discuss it in detail with examples in our subsequent sessions. Based on the principles of motion economy, and the purpose is why we are analyzing and subjecting the current method to the questioning technique, with a purpose to develop a better and a improved procedure. Then once we have found out, we have eliminated the unnecessary sequence of motions, we have resequenced, we have eliminated the unnecessary thermalics or ineffective thermalics, we have now developed a new method. So, a new SIMO chart is now prepared for the new method. The new method is now checked to claim its advantages over the old method. So, new method may claim that it is time saving, it is effort saving. So, we will compare both the current method and the new method by using the SIMO chart. This is an example of the SIMO chart on your screen. You can see it is SIMO chart. What is the work being done? Grasp the chisel, symbol is G. To the job, because the chisel is now in hand, it is transport loaded, TL. Then position, P, then hold, H. This is the description of the left hand. Then for the right hand, simultaneously what is being done? Grasp the hammer, G. To job, so transport loaded, idle. The left hand is positioning the chisel, right hand is holding the hammer. While the left hand is positioning, right hand is idle. Then it is holding the chisel, and with the hammer you are using the hammer or chiseling the wood. So, now you can see in case of two-handed process chart, these 4 micro motions could have easily been plotted with one or two symbols only, but here we have gone to an elemental level, a level below, and we have tried to identify the basic or the micro motions, that is grasping. What are the thermalics here? Grasp, then transport loaded, position, hold, all these are the thermalics. So from where we will get these thermalics? These thermalics have been recorded from the film or have been jotted down or written down from the film after analyzing the film. This is the time. From where we have got the time? The time has come from the device or the timing device. And left hand and right hand we have analyzed from the films, that what the left hand is doing and what the right hand is doing. So this is a simple description of a SIMO chart. Then we can see another type of a chart, finish hand filing of copper workpiece. So we have a copper workpiece and hand filing has to be done, finish hand filing. So here also we can see there is a left hand description, there is a right hand description, and the thermalics are given, the symbols are given. So just I will read for you. Left hand, first is searching and lifting with left hand, clamping the workpiece, do the hand filing operation, check the dimension, remove the workpiece. So thermalic inspection, checking the dimension, which we have seen in the previous session. Do the hand filing operation, use, U is used here. Clamping the workpiece, maybe position, clamping the workpiece, again there is position. Transport loaded, inspection by right hand also. So you can see that this is the time that is being depicted here. So here you can see that left hand description, right hand description, and the time as well as the symbols of thermalics are used. We will not read each one of these, but the main point is to emphasize that how a SIMO chart can be depicted. Now let us see, there is an important point to understand that what is the difference between a two-handed process chart, because in the previous two examples of SIMO charts we have seen that there is a left hand description, there is a right hand description, and then we are putting the thermalic symbols there as well as the time, a common time scale we are using. So what can be the difference? So here we have seen assemble of clamps and bolts. In this case, this is a layout also is shown here, this is the layout. Here we have the clamps in this box, we have a U bolt here, and these are the nuts in the central position. This is the main point. Assemble units have to be placed here. What is the job? Assemble of clamps and bolts. So effective time, left hand, right hand is given, ineffective time for left hand and right hand is given. The total cycle time is also mentioned. So here you see the left hand description, the right hand description. So get to the bolt, in case of for example a two-handed process chart, get to the bolt we may depict by transportation, but here the symbol used is R, E and G, that is reach and grasp, or transport, empty and grasp. So maybe that is one thing. Place U bolt. So here where three thermalics are coming into picture, that is M, position and RL. So in case of two-handed process chart, only we have major work elements or activities, but in case of micro motion analysis we use the thermalic symbols here. And similarly the time also you see is given in seconds here, time is given in seconds. Similarly for right hand you can see get the clamp. So for getting the clamp, two micro motions are there. For placing the clamp there are three micro motions here, M, P and RL. So from here it continues, hold the bolt, H symbol is there which is the thermalic. Time is also mentioned, that for 10.20 seconds you have to hold the bolt, and then your the right hand is performing different tasks during that time. When the left hand is holding the bolt, the right hand is doing other activities, and for that also thermalics are mentioned here. These are the thermalics. So, we can see that disposing of the assembly is done by the left hand. So, we can now compare the two, that in case of two-handed process chart we use the broader definition of the work elements. In case of SIMO chart we go to the micro motion level. The two-handed process chart, higher level depiction or higher level definition of the work elements, as is given here, get to the bolt or get U bolt. But in micro motion analysis using the SIMO chart we use in terms of thermalics, and the time is given in terms of wings. So, there is a difference between the two, that is the two-handed process chart and the SIMO chart. So, basically it depends when we have to select a particular recording technique or when we have to select a method study technique. In that case we have to be very sure that what we want to analyze. Now, suppose we want to analyze at the micro motion level, we will draw a SIMO chart. If we want to do at a normal level of analysis, we want to find out at a broader scale, we may use a two-handed process chart. If we want to analyze the complete organization at a, or we want to need to have a bird's eye view of the whole organization, we are not interested in how the worker is doing the job, we want to just see how the various sequence of operations or processes are being conducted in the organization, we may go for a operation process chart. So, depending upon the level of our analysis, we will select our recording technique, we will select our analysis technique, or we will, in broader sense we can say, we will select the technique that we are going to use for conducting the method study. So, with this we conclude the today's session. In next session we will focus, or in next week we will focus our attention on the standard steps that we need to follow for developing the better method. Although for each technique we have tried to see that what is the current method and what is the better or the best method, but now we will see with the help of examples or by the questioning technique how we can develop systematically a better method of doing the job. So, the technique can be any technique, but the standard procedure remains the same. So, let us see that how much we can cover in next week related to method study. It will be followed by work measurement, and finally we will finish the course with discussion on ergonomics. Thank you.